Hello students, today we'll be studying about the numericals on scheduling algorithms. This particular topic you will be studying in your embedded system as well as operating system subjects. Okay, first moving to the first scheduling algorithm, that is FCFS, first come first served. First come first served or FIFO scheduling is a one in which the process which comes at the beginning, that is the process which comes first to the ready queue, will be served first, later the next one, like that. Okay, now three process with process IDs, three processes with process IDs P1, P2, P3 with estimated completion time 10 milliseconds, 5 milliseconds and 7 milliseconds enters the ready queue together in the order P1, P2, P3. So P1, P2, P3 enters the ready queue together. Okay, but P1 takes 10 milliseconds to complete, P2 takes 5 milliseconds to complete, whereas 7 milliseconds is the completion time for your P3 process. Here, they what is the requirement here? They are asking us to calculate the waiting time and the turnaround time for each of these three processes and the average waiting time and the turnaround time. Okay, we have to calculate. Now, let us see what is this waiting time. Waiting time is nothing but the time that each process waits in the ready queue before its turns comes or before it completes there. Okay, this you will understand while solving the problem. Next, there is one more term that we have to calculate here, or we can say that there is one more unknown thing we have to find out. What is that? Turnaround time. To calculate this turnaround time, we have one particular formula. What is that? First, let's see what is the formula for that. Okay, here let me write TAT, turnaround time. It can be given as time that is spent in the ready queue plus the execution time of the process. Okay, time spent in the ready queue plus the execution time. Execution time is nothing but the time that each process takes to completes its execution. Okay, and time spent in the ready queue, that we can see that first there are two parts we can say here. Time spent in the ready queue in this is before we'll consider that particular process for the execution, it will wait for some time, that also we can consider. And in the next types of algorithms, we will stop the execution of the process at the middle and then we will schedule it once again. There also we can consider the waiting time, that we will see later. Okay, now turnaround time formula, you know, it is time spent in the ready queue plus the execution time. Now let's see how we can solve this. Okay, now first we will write down what and all things are given. Okay, first it is mentioned that there are three processes. That is the first thing we have to understand. Three processes are there. Okay, now we will write down their names. One is P1 and another one is P2 and the third one is P3. Okay, now we'll write down their completion time. What is written here? It is 10 milliseconds, 5 milliseconds and 7 milliseconds. Let's write that. Okay, now P1, it is 10 millisecond. For P2 it is 5 milliseconds. For P3 it is 7 milliseconds. Okay, it is 7 milliseconds. Now we have one very easiest method of solving this. For this, first we have to draw one rectangular box. With the help of this, we can easily find out the waiting time as well as the turnaround time. Let's draw that. Now, let us divide this according to the three processes. Okay. Now, okay. First one is P1, next one is P2, and the third one is P3. We have written. Now, what is given? They will enter the ready queue together. So, we will consider P1 at the beginning. Now, let us consider this rectangular box as my ready queue. Okay, so if I consider this box as my ready queue, at what time P1 enters, we can say they'll enter together. Okay, so at that time P1, P2, P3 are available. Now we will consider the next part, that is their execution time and completion time. They'll enter the ready queue together. So P1 first, P2 second, P3 third process. So let me start by writing that 0 milliseconds. Okay, we can say that P1 starts with 0 milliseconds. Is that okay? Now, how much time P1 takes to complete? Okay, that we have to write. Whether P1 waits there? No, because as the P1 enters, we will be giving chance for P1 itself. So we will start with 0 milliseconds. Now, how much time P1 takes? That we have to write over here. Okay, so let us consider it as 10 milliseconds. I will write my 10 milliseconds over here. Now this is the time my P1 takes. Next, which enters the ready queue, which we are allocating now, that is my P2 here, isn't it? So now tell me, after this 10 milliseconds, P2 comes into picture. How much time my P2 takes to complete? Here it is written as 5 milliseconds, isn't it? So here it is 10 milliseconds already. Now 5 more milliseconds will be taken by this P2. So here we can say it is 15 milliseconds. Okay. Now after this 15 milliseconds, we can say P1 and P2 completes the execution. Now which one comes into picture? P3. Now we will see how much time P3 takes. Here it is 7 milliseconds. So at 15 milliseconds P3 comes, at 10 milliseconds P2 comes. P2 comes at 10 milliseconds and it takes 5 milliseconds for the execution. So it completes at 15 milliseconds. So P3 comes at 15 milliseconds. So it takes 7 milliseconds for the execution. So we can say that P3 completes at 15 plus 7, that is 22 milliseconds. Okay. Now it is done. Now we will see what is this time. What is the time taken by P1? It is 10 milliseconds. Let me write here. Here it is 5 milliseconds, isn't it? Now here this particular time P3 takes is 7 milliseconds. Okay, this particular structure is very important. This helps in solving the problem very easily. Now we have to calculate waiting time as well as the turnaround time. For this we will usually draw one table. Let's draw that table first. Okay, now let me write process here. Okay, now after process, let me put a line over here and then let me write waiting time. I'll write waiting time over here. Next, what is the thing we have to calculate? It is my turnaround time. Let me write it as TAT. I have written. Now we can calculate it. What are the different processes that are present? P1, P2, and it is P3. Now, now you consider this particular diagram. How much time this P1 takes? Or in this case, we are calculating the waiting time. So we can say that how much time P1 waits before it starts its execution. since we know it is first come first serve based algorithm, so P1 enters first, so we are not giving any waiting time for this P1. As soon as P1 comes to the picture or comes to the ready queue, we will consider it for the execution. So we can say that 0 milliseconds is the waiting time for my P1. Now, turnaround time, you know what is that formula? It is time spent in ready queue plus the execution time. What is the time that is spent by P1 in the ready queue? Actually, we know as soon as P1 arrives, we are allowing it for the execution. So we can say that 0 milliseconds is spent by the P1 in the ready queue. We are not allowing P1 to wait there. As soon as it comes, we are serving it with the execution time. Or we can, in other words, we can say that as soon as P1 comes, we are allowing for its execution. Allowing it for execution. Now, 0 milliseconds is the time spent in the ready queue. Now, what is the execution time? How much time this P1 takes for its execution? It is 10 milliseconds. So let me write 10 milliseconds. So it is 0 plus 10. So I can write it as 10 milliseconds over here. Next, coming to the P2. Here in this case, we can say that though P1, P2, P3 arrives together, P2 waits until P1 completes, isn't it? So here you can see P2 waits till 10 milliseconds, okay, before starting its execution. So waiting time for P2 is 10 milliseconds over here, okay. Now, coming to the turnaround time. Time spent in the ready queue by the P2 plus the execution time of it. What is the time spent in the ready queue? We can say it is 10 milliseconds, isn't it? Plus, what is the execution time for the P2? It is 5 milliseconds, isn't it? So, 10 plus 5, so it is 15 milliseconds. Similarly, for P3, if you consider what is the waiting time for P3, it waits till P1 and P2 completes their execution. So we can say that the waiting time for this P3, it starts at this 15 milliseconds, you know. So we can write it as 15 milliseconds over here. Okay, that is done. Now next, what is this turnaround time? Time spent in ready queue by the P3 and the execution time of P3. So I can write it as time spent by P3 in the ready queue is 15 milliseconds plus the execution time of my P3, it is given as 7 milliseconds, isn't it? So 15 plus 7, if I do that calculation, it comes around 22 milliseconds. Okay, now you have got the waiting time for all the three process as well as the turnaround time. Now, what was the question? We have to calculate the average waiting time and the average turnaround time. So since you got three values for this waiting time, if you calculate the average, it will be 0 plus 10 plus 15, all values divided by 3. Okay, here it is 10 milliseconds plus 15 milliseconds plus 22 milliseconds divided by 3. 10, 15 and 22 by 3. So if you calculate this using your calculator, you will get this value around 8.33 milliseconds. Okay, if you have calculator, you can verify it. And average turnaround time, it will be around 15.66 milliseconds. This is the average of your waiting time. This is the average of your turnaround time. Okay. Now, this is what is asked in the question. We have calculated the waiting time as well as the turnaround time for FCFS scheduling. Now let us move to the second scheduling algorithm. What is that? Second algorithm, what we have here is a last come first served. As the name indicates, it is LCFS or it can also be called as LIFO. What is this? So Here what happens is that in the ready queue, okay, processes will come, but we will consider the last come process first and the first come process at the last. Okay, while solving we will understand this. Unlike the last problem, here we are having three different points to consider. Okay, first let us see the first point. What is there? Three processes with process IDs P1, P2, P3 with the estimated completion time 10, 5, 7 milliseconds enters the ready queue together, but their order is P1, P2, P3. Okay, now in the bracket they have given one instruction. What is that? Assume only P1 is present in the ready queue when the scheduler picks it up, and P2 and P3 enter the ready queue after that. Okay, first P1 will be there in the ready queue, so the scheduler will pick P1, but P2 and P3 enter the ready queue after the scheduler picks P1. Okay, now next we will go to the second part of the question. Now they are telling one more statement here. What is that? Now a new process P4 with the estimated completion time 6 milliseconds enters the ready queue after the 5 milliseconds of scheduling P1. Okay, now P1 was executing, or P1, when P1 was executing, P4 comes. But at what time it comes? New process P4 with a completion time of 6 milliseconds enters the ready queue after 5 milliseconds of scheduling the process P1. Now let us focus on what we have to find. What is our work here? We have to calculate the waiting time, turnaround time for each of these processes P1, P2, P3 and P4, and we have to calculate the average waiting time and the average turnaround time. Okay, and we have to consider that all the processes contain only CPU operation and no input output operations are involved. So at the beginning we had P1, P2, P3, but P4 enters. Okay, now the name of this algorithm is last come first served, isn't it? So now we will see how we can solve this. Okay, first you understand only P1 will be present in the ready queue when the scheduler picks it up, but P2 and P3 enters the ready queue later. Okay, we can say it is given there, but after that P4 enters. It is a new process, its completion time is 6 milliseconds, but it enters after 5 milliseconds of the scheduling of your P1. Now let us see how we can solve this. First, same way we have to draw one rectangular box. Okay, but before that it is better to write down all the statements whatever is known. First we will start with our P1. Okay, P1. P1, its completion time was given as 10 milliseconds. So let me write that as 10 milliseconds. Okay. Next P2, its completion time was given as 5 milliseconds. If you want, you can copy the questions by pausing the video and later you can go for solving. Next, coming to the third process P3, its completion time is 7 milliseconds. I am writing that also. Okay. Now, in the order, what is that order? In the order only we have written here P1, P2, P3, P3. But this is the first thing we have to note. And coming to the second point, this is the first point. Coming to the second point, P4 enters. Okay. But what is the completion time for that? It is 6 milliseconds. P4 enters ready queue after what? Let me write that full sentence. After 5 milliseconds of scheduling which process? P1. These are the two important statements we have to know. Now let us draw that rectangular box. This actually is helpful in scheduling the processes. Okay. Now, at the beginning, as we know, P1 will be there. Okay, what is the completion time? It is 10 milliseconds. But we know P4 enters the ready queue after the 5 milliseconds. So we can say that at 0 milliseconds, P1 was executing. Okay, now what is the next thing? It is last come, first served, isn't it? So P1 will come first. So after P1, which was the last thing that came? That was P4, isn't it? Though P1, P2, P3 was there, first we have picked up P1, but after that our priority has to be given to the last come process. So we are giving time for our P4 now. After that, if you consider last come process, it is P3, and then comes your P2. Okay, I hope you are understanding. Now here at 0 milliseconds, P1 comes. How much time P1 takes for the completion? It is 10 milliseconds, isn't it? So it executes for 10 milliseconds. Next, after 10 milliseconds, what comes to the picture? It is P4. What is the time taken by P4? It comes after 5 milliseconds of scheduling of P1, but completion time it takes is 6 milliseconds. So I can write it here as 16 milliseconds. Is 16 milliseconds. Here it is sent. So I can write here it is 10 milliseconds, isn't it? P1 executes for 10 milliseconds. So at 10 milliseconds, P4 comes. So here it executes for 6 milliseconds. We are scheduling P4 here, though P3 and P2 is there because it is last come, first served. Next, here P3 will start. Okay, at 16. I will write 16 over here, and it executes for how much time? For 7 milliseconds. So I will write the 7 milliseconds over here. Okay, so it comes at 16 milliseconds, it takes 7 milliseconds, so we can say that it completes at around 20 23 milliseconds. Okay, now what is the time that is taken by P2? It takes 5 milliseconds. So I can say that here it is 28 milliseconds. Okay. One more time I'll explain. At beginning, at 0 milliseconds, P1 comes. It executes for 10 milliseconds. So I have written 10 milliseconds. So after 10 milliseconds, P4 comes because it is the last process. So P4 enters and it takes 6 milliseconds. So 10 milliseconds it comes over here. 6 milliseconds it takes. So P4 ends at 16 milliseconds. So here what happens is that at 16 milliseconds P3 comes. It takes 7 milliseconds. So I have written 7 milliseconds. So at 23 milliseconds P1, P4, P3 completes execution. But P2 comes there at 23 milliseconds. It takes 5 milliseconds for the completion. So P2 completes at 28 milliseconds. Okay, now I have written 10 milliseconds, 6 milliseconds, 7 milliseconds as well as the 5 milliseconds. Okay, now we will draw that particular table, that is process, next waiting time. Okay, I have written waiting time. Next I have to write turnaround time. Okay, now let me write the process in the order that I am written in this particular rectangular box. Okay, not the other order. This, because of this, you will not miss any process, and you will not mix any process. Okay, P4, after that it is P3, next is P2. What is the waiting time for P1? Whether it waited for any time? No, so it is 0 milliseconds. Next, coming to the turnaround time, here it is time spent in the ready queue plus the execution time. I am repeating that particular formula because that is very important in solving this problem. Next, what is the time spent in the ready queue by P1? It is 0 milliseconds. Okay, what is the execution time for my P1? It is written over here. It is 10 milliseconds. seconds, isn't it? So I will write it as 10 milliseconds here. So the sum is 10 milliseconds. Now coming to the P4. Okay. Now it is written P4 enters the ready queue after 5 milliseconds of scheduling the P1. So completion time for P1 is 10 milliseconds. So P4 enters after 5 milliseconds. So we can say that P4 waited only for rest of the 5 minutes. Sorry, 5 milliseconds. Okay. Now what is the turnaround time for this? 5 milliseconds. It waited in the ready queue. Next, what is the execution time for my P4? Here it is written as 6 milliseconds. So I can say it is 11 milliseconds, isn't it? Okay. Now coming for the P3. Okay. What is the time that P3 spent in the ready queue? Okay. Here if you check, P3 enters the ready queue at 16 milliseconds, isn't it? It waits until P1 completes for 10 milliseconds and P4 completes for 6 milliseconds. So totally we can say it is 10 plus 6, 16 milliseconds over here. Now what is the turnaround time? The time spent by it in the ready queue will be 16 plus the execution time for my P3 is 7 milliseconds, isn't it? So it is 16 plus 7. I can say it is how much? 23 milliseconds. Now coming to the P2, it enters the ready queue at 23 milliseconds, isn't it? So it waited in the ready queue for 23 milliseconds. It comes for the execution at 23 milliseconds. So I can say that it waited for 23 milliseconds in the ready queue until all P1, P4, P3 completes their execution. So turnaround time for it is 23 milliseconds plus this 23 milliseconds plus what is that next thing what we have here? Can you tell me? It is the execution time for P2, that is 5 milliseconds. It is 28 milliseconds. Now you got all the four values. We have to calculate the average. 0, 5, 16, 23. We have to find the sum of these divided by 4. Here also 10 plus 11 plus 23 plus 28 we have to do. Then we have to divide by 4. Now, can you tell me what is the answer for this? If you just tell me it is 11 milliseconds, you can verify average waiting time is 11 milliseconds, whereas average turnaround time I will get as 18 milliseconds. Okay, this is the way for solving the problem for last come first served, LCFS or LIFO. Next we have one more algorithm. What is that? Shortest job first algorithm. As the name says, here processes will come to the ready queue, but we will select the one which will complete at very short amount of time or small amount of time. So it is given shortest job first, which is quick, that we will consider at the beginning. Now we will consider the statements what is given there. Two part is there for the statement like the previous problems only. First one, three processes with process IDs P1, P2, P3 and their completion time is 10 milliseconds, 5 milliseconds, 7 milliseconds enters the ready queue together. But what is our work here? We have to calculate the waiting time and the turnaround time for each of these process and the average waiting time and the turnaround time for the P1, P2 and P3. Here we have to consider the shortest job first. So now you are solved two types of scheduling algorithm problems. Now you can say which one we are considering at the beginning, that is P2 because its completion time is very less, that is 5 milliseconds. Next we'll go for P3, isn't it, because it takes 7 milliseconds to complete. Next last one is our P1 process because it takes large time, that is 10 milliseconds for completion. Let's start solving. Now first same step, we have to write P1, isn't it? Next we have to write P2. After that P3. Okay. P1 takes 10 milliseconds, isn't it? P2 takes 5 milliseconds, whereas my P3 takes 7 milliseconds. Now my work is to draw the rectangular box. Okay. Now this is 0 milliseconds. No change here. It is 0 only. Okay. Now first we have to consider the shortest job, that is P2. So let me consider P2 here. Next P2 is considered, but how much time it executes? It executes for 5 milliseconds. Here it is given. So I will consider that 5 milliseconds over here. So after that, we can say that at 5 milliseconds, P2 completes. So next, which comes for the execution? That is the next shortest job, that is P3. So I will start with my P3 execution. How much time it takes for the execution? It takes 7 milliseconds. So it enters at 5 milliseconds. It takes 7 milliseconds for the execution. So I can say that P3 completes at 12 milliseconds. Now last process P1 comes into picture. What is the completion time? At 12 milliseconds it comes, but it executes for 10 milliseconds. So I can say that P1 completes execution at 22 milliseconds. Now by seeing this particular table only, we can find out all the turnaround time and the waiting time, isn't it? How? Because if you add these two values, 0 plus 5, you will get the turnaround time for the first process. Similarly, if you add these two values, you will get the turnaround time for P3, and similarly if you add these two values, you will get the turnaround time for your P1. Okay. Now let us draw that particular table process. Next, waiting time. Next comes turnaround time. Okay. Now we will write P2, P3, P1. How much time P2 waited? It is 0 milliseconds. So turnaround time, here if you consider it waited for, let me write it at the beginning. Later we'll see whether this particular way works or not. First P2 waited for 0 milliseconds and it executes for how much time? 5 milliseconds. So it is 0 plus 5, that is 5 milliseconds. Okay. Now next coming for P3, at 5 milliseconds it enters, so we can write here 5 milliseconds is the waiting time for P3. So it is 5 milliseconds plus it takes 7 milliseconds for the execution, so I will write 7 milliseconds over here. It is 12 milliseconds over here. Okay. Next coming to the third process, that is P1. P1 comes for the execution at 12 milliseconds, so I can say it waited for 12 milliseconds. After that only it enters. Next 12 milliseconds it waits, or we can say that it is the time spent by P1 in the ready queue. Okay. Now you can see that these waiting time what you are writing here, that is the only thing what you are writing here in calculating the turnaround time. So this is same as the waiting, we can say that waiting time is same. In this case it is same as time spent in the ready queue, 0 milliseconds, 5 milliseconds, 12 milliseconds. Next, what is the execution time for P1? It is 10 milliseconds, isn't it? So it is 12 plus 10, 22 milliseconds. Now if you see 0 plus 5 is what is here. Now here also you can see it is 0 plus 5. Next I told you have to add 5 plus 7 to get the turnaround time for the P3. So that is the same thing what we are adding. Next it is 12 plus 10. Here it is 12 plus 10. I hope you are understanding. Now we will calculate the average values. Now if you calculate the average of 0, 5, 12, it will come around 5.66 milliseconds. Okay. In the same way, if you try to find out the average turnaround time, you have to add 5, 12, 22 divided by 3. You will get the average as 13 milliseconds. Okay. This is how you can solve for shortest job first algorithm. Next, we will go for another kind of scheduling algorithm, that is priority based scheduling. Here, till here, what we are considering is their arrival time, whether arrival condition, whether it arrives first, arrives last. Like that, we have scheduled them for scheduled processes for the execution. Okay. And we have considered their execution time, whether it executes for short amount of time, large amount of time, like that. So next we have one algorithm called as priority based scheduling. So we will consider the priorities of all the processes. Based on their priority, we will be selecting the processes for the execution. Okay. Now let us go for that. Priority based scheduling. Like the previous problems, here also we can see the two conditions, two statements in the same problem. What is that? First, what is given? Three processes will be there with the process IDs P1, P2, and P3. Okay, their estimated completion time is 10, 5, 7 milliseconds. But here, since the name is given priority based scheduling, so we have to consider the priorities of P1, P2, P3. Okay, and that priority is given there. 0 is the highest priority and 3 is the lowest priority. Okay, isn't it? But they have given process 1 has a priority of 0. Here it is given. Process 2 has a priority of 3 and process 3 has a priority 2. 0 is the highest priority, 3 is the lowest priority, isn't it? So we can say that here highest priority one is a P1 process because its priority is 0. Next highest priority is for your P3 and the last priority is given for P2. Okay, now what is our work? Same work. We have to calculate waiting time, turnaround time, average of waiting time and the turnaround time. Okay, now let's start. First, write down the requirements. Here, along with their completion time and process IDs, you have to consider the priorities also. Okay, so while solving these problems, read the questions carefully and write down the requirements. Like, write down the requirement, like what is required. Waiting time you have to calculate, turnaround time you have to calculate. What and all datas are given, their IDs, completion time, priority, everything you have to write down. Now, P1 is the first process, so let me write P1. Okay, now what is the completion time? 10 milliseconds, I will write that. Next, P2 5 milliseconds, so let me write that also. P2 5 milliseconds, I have written. Next, P3 7 milliseconds, I have written that also. Now, priority order, if you consider, 0 is the highest priority, 3 is the lowest priority. So I will write P1 priority is 0. Here it is written. P2 priority is 3. P3 priority is 2. Isn't it? So P1 priority 0. P2 priority 3. P3 priority it is how much? 2. Okay. I have written that. Now 0 is the highest priority, whereas 3 is for lowest priority. Okay. Now same way, draw the rectangular box. 3 processes, so 3 box within that. starting with 0 milliseconds. We have to consider the one with highest priority. So we have to consider P1. Let me consider P1 first. What is the completion time for that? It is 10 milliseconds. So P1 executes for 10 milliseconds. So at 10 milliseconds it completes. So next priority process will come at 10 milliseconds. What is that? It is P3. P3 comes at 10 milliseconds. It executes for how much time? P3 is 7 milliseconds, isn't it? So I will write it here as 7 milliseconds. So at 17 milliseconds, P3 stops, whereas P2 comes into picture. P2 comes at 17 milliseconds. It takes how much time? 5 milliseconds for the execution, isn't it? So P2 completes at 22 milliseconds. So for the turnaround time, you can add these two values. This is a shortcut, but you have to write this particular rectangular box and these values properly. Then only you can calculate turnaround time correct. Otherwise, you will go wrong. Next, writing the table. Process, waiting time. Okay. Next is my turnaround time. What is that? P1, P3, P2. P1 waited for 0 milliseconds. So it waited for 0 milliseconds in the ready queue, or the time spent by P1 in the ready queue is 0 milliseconds. It executes for 10 milliseconds, isn't it? So it is 10 milliseconds over here. Next for P3. Time spent by P3 in the ready queue is at 10 milliseconds it comes. So it waited for 10 milliseconds. I will write that 10 milliseconds over here. Plus what is the execution time for P3? It is 7 milliseconds. So it is 17 milliseconds. Next, P2, right? It comes at 17 milliseconds. So I will write that 17 milliseconds directly over here. And here it is 17 milliseconds plus the execution time for P2 is 5 milliseconds. So it is 22 milliseconds. So if you add 0 plus 10, 10, 10 plus 7, 17, 17 plus 5, 22. Now it is time for you to calculate the average of these three values. Okay, so if you calculate the average of 0, 10 and 17, you will get the value as 9 milliseconds. And if you calculate the average of 10, 17 and 22, you will get the value as 16, wait, 16.33 milliseconds. It is 16.33 milliseconds. This is for priority based scheduling. Okay. Next, we will go for one more kind of algorithm. But here we have one more thing to consider. What is that one more special thing we are considering? That is preemption. So, since I am focusing only on the numericals here, now in brief, if I tell you what is this preemption, in the sense, if one process is executing, we will stop the execution of that in middle, then we will allocate that, or we can say that we are scheduling one more process in the execution. Understanding? First, let us consider P1 is executing. Okay, due to some reason we will stop the execution of P1 and we will consider P2 for the execution. Once that P2 comes, we will then allocate P1 again to complete. Okay, what is that special reason? Everything we will see while seeing the problem statement. Now, here also two things we have to consider. Okay, three processes. So the name is preemptive SJF scheduling, shortest remaining time. Here we are doing the problem or considering the shortest job first only, but preemption is there. Okay, now three processes with process IDs P1, P2, P3 with estimated completion time 10 milliseconds, 5 milliseconds, 7 milliseconds respectively enters the ready queue together. But here it is given a new process P4 with estimated completion time 2 milliseconds enters the ready queue after 2 milliseconds. Okay. Assume all the processes contain only CPU operation and no input output operation. Now, I told depending on one thing or one special condition, you can stop the execution of one particular process and you can start the execution, or you can schedule the second process, isn't it? Here in this case, it is given shortest job first. So, if you consider P1, P2, P3, their completion time is 10 milliseconds, 5 milliseconds, 7 milliseconds. So, in general, what we have to do here, we have to consider P2 for the execution because that is the shortest job. But here, since the one more process P4 enters, but its completion time is 2 milliseconds, isn't it? It enters the ready queue after the 2 milliseconds. So, usually based on our SJF rule, we have to consider P2. But since preemption is there, we can now compare the completion time of the new process P4. It is having the completion time 2 milliseconds, which is really less compared to the P2 execution time 5 milliseconds, isn't it? So now we have to stop the execution of P2 and we have to schedule P4 because it is the shortest job we are having now. Once we will complete the execution of P4, then we can allocate P2 for the execution, or we can say that we can schedule P2 for the execution. Now we will see, or we can understand it very well when we solve the problem. Okay. Now I'm focusing only on the problem, so I'm telling the theory that which is required for you to solve the problem. Okay. Now preemptive SJF scheduling. First step, write the data that is given. P1 10 milliseconds. Okay. P2 5 milliseconds. Next, P3 7 milliseconds. Isn't it? I have written them. Next, P4 enters after 2 milliseconds completion time 2 milliseconds. Isn't it? So we can write P4, its completion time is 2 milliseconds. Okay, but it enters after 2 milliseconds. Completion time is 2 milliseconds. It enters after 2 milliseconds. Okay. Now we will write the table. Here little bit this problem is tricky. You will understand this. Now first, at 0 milliseconds, by considering these three processes, shortest job we have to consider. So we have considered P2. Okay. Now P2 is executing. Okay. P2 is executing. Let's not write the complete completion time because here it is preemption. Now P4 enters after 2 milliseconds. So now P2 is executing. Its time is 5 milliseconds completion time. P4 enters with, at what time it enters? After 2 milliseconds. Its completion time is 2 milliseconds, which is less than P2. So after 2 milliseconds of execution of P2, we will schedule P4. Okay. So we can say here P2 executes for 2 milliseconds. Now P4 has arrived. It executes for 2 milliseconds. Now what is the time over here? Can you tell me? Here it is 4 milliseconds. Now P4 is done. Now again if you consider P1, P2, P3, the shortest job is P2. So P2 will be scheduled. Now we have to notice here its completion time is 5 milliseconds, but it executed for 2 milliseconds at the beginning. So now we can schedule this P2 only for 3 milliseconds. Then we can say that P2 will be completed. So this is 7 milliseconds. Now P2 is done, P4 is done. Now the next shortest job is P3. So at 7 milliseconds, we can say that P3 enters. Okay. Now P3 executes for 7 more milliseconds. Now After execution of P3 for 7 milliseconds, no one is there to interrupt the execution of P3. So I can say that after 14 milliseconds, execution of P3 completes. So at this particular time, P1 comes. Okay, P1 executes for 10 milliseconds. So P1 takes totally 24 milliseconds for the execution. Okay, now we will draw the table. Process, waiting time. Now this is really little bit tricky. Here we have to understand the problem. Okay, now first P2 is there. Next we will write P4. No need to write P2 again because we will write the waiting time. We'll consider waiting time here only. Next P3. After that P1. P2, P4, P4, P3, P1. Okay. Now here at this particular time P2 waited for 0 milliseconds. So let me consider that now. But here because of the interruption of this P4 or the when P4 arrives we considered P4. So here P2 waited until this P4 completes. So we can say that P2 waited for 2 milliseconds until this P4 completes. So we can say that 2 milliseconds is the waiting time. Okay. So here it is 0 plus 2, 2 milliseconds. Now what is the turnaround time if you consider? It waited for 2 milliseconds. Execution time for that is 5 milliseconds. So here it is 7 milliseconds. Now P4, it didn't wait only because as soon as it enters the ready queue after 2 milliseconds, its execution started. So it is 0 milliseconds. So I can calculate the turnaround time for it as 0 plus execution time is 2 milliseconds, 2 milliseconds. Okay. Now for P3, P3 it waited for this 2 milliseconds at the beginning. Next 2 milliseconds. First it waited for 2 milliseconds of P2. Next waited for 2 milliseconds of P4. Again waited 3 milliseconds for P2. So I will write here as 2 milliseconds plus 2 milliseconds plus 3 milliseconds. So totally it waited for 7 milliseconds. Okay, 7 milliseconds. Now 7 milliseconds waiting time plus 7 milliseconds for its execution. So it is 14 milliseconds. Okay, now coming for P1. P1 waited for the first 2 milliseconds of P2, then 2 milliseconds for P4, 3 milliseconds for P2, 7 milliseconds for P3, 2 milliseconds, 2 milliseconds, 3 milliseconds, 7 milliseconds. Okay, so I can write it as 2 plus 2 plus 3 plus 7, 14 milliseconds. Okay, so I will write 14 milliseconds plus the execution time is 10 milliseconds. Here it is 24 milliseconds. Now if you take the average, here we have to consider average for 2, 7 and 14. Here it is 7, 2, 14, 24. Okay, here 2 plus 0 plus 7 plus 14 by 4, 7 plus here 7 plus 2 plus 14 plus 24 by 4. Here it is 5.75 milliseconds. Okay, for the turnaround time if you calculate the average it is 11.75 milliseconds. Waiting time average is 5.75 milliseconds. Turnaround time average is 11.75 milliseconds. Okay, now let us go for the last but one scheduling algorithm, that is round robin scheduling. Okay, Now, let's go for the problem statement. First part. Three processes with process IDs P1, P2, P3 with estimated completion time 6, 4, 2 milliseconds respectively enters the ready queue together in the order P1, P2 and P3. Okay. Next, what we have to do? We have to calculate waiting time and the turnaround time. Okay. But there is one more thing they have given. What is that? In the last statement, if you see, in the RR algorithm with time slice 2 milliseconds, isn't it here? What is this? Here we have to schedule the process only for 2 milliseconds each. Okay, then they will form a circular fashion loop. So they will take 2 milliseconds for the execution. After so many 2 milliseconds are over, then they will complete. That we will see now. Okay. Now, first we will write the given data. What is that? P1 6 milliseconds, isn't it? P2 4 milliseconds, P3 2 milliseconds. Let me write P2 4, P3 2 milliseconds. P1 6, P2 4, P3 2 milliseconds. Now we will write down that time slice also. Okay, RR time slice. It's very important, 2 milliseconds. Now while solving, we will get to know what is the significance of this time slice. Okay, first we will draw one big rectangular box. Okay. First, at 0 milliseconds, which comes at the beginning P1. It executes for the time slice, it is given as 2 milliseconds, so it executes for 2 milliseconds. Okay, but it didn't complete its execution. After 2 milliseconds, P2 comes. So I will write P2. P2 also executes for 2 milliseconds because we are considering this time slice. Now, after 2 milliseconds, we have to consider P3. Okay, P3 is scheduled. Now, this P3 also executes for 2 milliseconds. Now, you can see P1, P2 has not completed because their completion time is 6 milliseconds and 4 milliseconds. But if you consider P3, its completion time is 2 milliseconds. So P3 completed here. Okay. Now, after this, again P1 comes into picture. Again, time slice is 2 milliseconds. It executes for 2 milliseconds. Next, who will come? P2 will come. It executes for 2 milliseconds. Now, we don't have P3 because it has completed here only. So, now you know P2 executed for 2 milliseconds at the beginning and now it executed for 2 milliseconds. Its completion time was given as 4 milliseconds. So, even P2 completed the execution time 4 milliseconds. Now the only process that is left is P1, isn't it? Now P1 executed for another 2 milliseconds of time. Now P1 executed here, here, here. So it is P1 over here, then again P1 executed over here and again it executed over here. So it is 6 milliseconds altogether. Okay. Now we will write the table. Okay. Now I will write the table. process, isn't it? Next, waiting time. Next comes the turnaround time. Okay, what are the processes here? P1, P2 and P3. Okay, now if I consider the waiting time. Okay, first P1, it waited for 0 milliseconds. I'm writing here by considering this particular execution of P1. Next, it scheduled here P1, isn't it? So we can say that it waited for 2 milliseconds of P2 and 2 milliseconds of P3. So I will write it as 2 plus 2, 4 milliseconds. Next, again it executed here after 2 milliseconds of P2. So I will write 2 milliseconds again. So totally it is 6 milliseconds, isn't it? Now turnaround time. It waited for 6 milliseconds. Next, its execution time for P1 is also 6 milliseconds. So its turnaround time is 12 milliseconds. Now if I consider P2, P2 executed for, waited for 2 milliseconds of P1 here. I have written. Next, again P2 came after 2 milliseconds of P3 and P1. So I will write it as 4 here, 4 milliseconds. So it is 6 milliseconds again. So here turnaround time is 6 milliseconds plus its execution time is 4 milliseconds. I will write it as 10 milliseconds. Now coming for P3, it waited for 2 milliseconds of P1 and 2 milliseconds of P2, isn't it? So first I will write 2 milliseconds plus 2 milliseconds. So I will write it as 4 milliseconds together because here it is 2 plus 2, right? So I will write it as 4 milliseconds directly. Okay. Now, so I will write 4 milliseconds directly. Next, here it is 4 milliseconds plus its execution time is 2 milliseconds. So it is 6 milliseconds. 4 milliseconds here, waiting time plus the execution time is 2 milliseconds, 6 milliseconds. Now if I take the average of 6, 6, 4, I will get 5.33 milliseconds. Whereas here if I consider it is 12 milliseconds, 10 milliseconds, 6 milliseconds. So if I consider the average, it will be average of 9.33, average of three values, it will come around 9.33 milliseconds. Okay, now moving to the last scheduling algorithm. Here also we will be executing by considering the priority. So priority based scheduling. Okay, now let's move on to the last scheduling algorithm, numerical. Priority based scheduling. Here, first we have to go through the statements. First part of statement. Three processes with process IDs P1, P2, P3 with estimated completion time 10 milliseconds, 5 milliseconds and 7 milliseconds. But here we are given with the priorities. Priorities of 1, 3, 2. 0 is the highest priority, 3 is the lowest priority, respectively enters the ready queue together. So they are telling us that P1 is the process with the highest priority, P3 is the process with the second highest priority, and P2 is the process with the last priority or lowest priority. Okay, respectively enters the ready queue together. But they are telling you that a new process P4 with the estimated completion time of 6 milliseconds and the priority 0 enters the ready queue after 5 milliseconds of start of execution of P1. Now, they told 0 is the highest priority. I didn't mention about 0, isn't it, at the beginning, because I told P1 is the highest priority, P3 is the second highest, P2 is the lowest priority, because 0 was not in the picture. But they are telling that a new process P4 and its completion time is 6 milliseconds, its priority is 0. We can say that this is the process with the highest priority. It will enter the ready queue after 5 milliseconds of start of execution of the P1. Okay, now we have to calculate the waiting time and average waiting time, turnaround time and average turnaround time for P1, P2, P3 and P4. Okay, now we will start with the same step: writing the data, drawing the table, writing the data, drawing the rectangular box, then drawing the table. Okay, now first we will write whatever things are given. Okay, P1 10 milliseconds. Okay, P2 5 milliseconds, P3 7 milliseconds. Okay, now their priorities 1, 3 and 2. Priority I will write 1, here it is 3 and here it is 2. Okay, now P4 enters with a completion time of 6 milliseconds. They are telling us that P4, its completion time is 6 milliseconds. Okay, it enters the ready queue. Okay, but after 5 milliseconds of P1. So first I will write the priority here, and I will write after 5 milliseconds of P1. Okay, now let us draw the rectangular box. First, at 0 milliseconds, now we have to consider the process with the highest priority, that is P1 only. But it executes only for 5 milliseconds. Here they are telling now the highest priority is 0. That priority value is there for P4. It enters with completion time of 6 milliseconds after 5 milliseconds of P1. So P1 only executes for 5 milliseconds. Then at 5 milliseconds, P4 comes. Okay, but P4 executes for 6 milliseconds. Okay, now at 11 milliseconds, P4 completes its execution. Now we have to again consider the old priorities of 1, 3, 2. So P1 comes here. At 11 milliseconds, P1 comes for the execution again, and its total completion time was 10 milliseconds. It executed for 5 milliseconds. Now again it executes for 5 milliseconds more. Then P1 completes after 16 milliseconds. At 16 milliseconds, P1 completes. Next, we have to check for the priorities of P3 and P2. So P3 comes at 16 milliseconds. P3 executes for 7 milliseconds. So P3 completes its execution at 23 milliseconds. Okay. Now, at this 23 milliseconds, P3 completes. So last priority process is P2. It comes at 23 milliseconds. It executes for 5 milliseconds. Completion time is 5 milliseconds. And the execution of P2 also completes at 28 milliseconds. Now we will draw the table. Process. This won't change. Waiting time. And then comes turnaround time. So I will write P1, P4, P3, P2. P1, P4, P1 is already considered, so P3, P2. Okay. Now P1. At the beginning, it waited for 0 milliseconds. So I have written 0. Next, it waited for how much time? 6 milliseconds of P4. So I will write 6 milliseconds here. So here it is 6 milliseconds. Okay. 0 plus 6, it is 6. Now let us consider the turnaround time. So 6 milliseconds waiting time plus execution time for P1 is 10 milliseconds. So here it is 16 milliseconds. Next, coming for P4. P4 waited for 5 milliseconds of P1 here. So if you want to calculate the turnaround time, isn't it? Is it correct? Now if you see, this 5 milliseconds is not possible because we told as soon as P1 executes for 5 milliseconds, P4 comes and P4 is given the execution time because P4 is scheduled because of its highest priority. So I can say that P4 didn't wait. As soon as it comes to the ready queue, it was given. So here it is 0 milliseconds. Okay. Next. So I can say that 0 milliseconds here plus it executed for 6 milliseconds. I will write this 6 milliseconds and here it is 6 milliseconds. I hope you are understanding. P4 didn't wait for 5 milliseconds. In this table we have written, but actually you have to see this highest priority and its statement there. Enters after 5 milliseconds of P1. Next, coming for P3. P3 waited for how much time? 10 milliseconds of P1 and 6 milliseconds of P4, isn't it? So here at the beginning, it waited for 5 milliseconds. So I will write 5 milliseconds. Next again, it waited for 6 milliseconds, isn't it? So I will write that 6 milliseconds. Then again, it waited for 5 milliseconds of P1. So it is 16 milliseconds. Now if I want to calculate the turnaround time, it is 16 milliseconds plus what is the execution time for P3? It is 7 milliseconds. So 16 plus 7, it is 23 milliseconds. Now if I want to calculate for P2, P2 waited for P1, P4 and P3 processes. Okay, so it waited for 5 milliseconds, 6 milliseconds, 5 milliseconds, 7 milliseconds. Okay, isn't it? Now we will write that 5 milliseconds of P1, 6 milliseconds of P4, again 5 milliseconds of P1 plus 7 milliseconds of P3. 5, 6, 5, 7. 5, 6, 5, 7. So total if you calculate it is 23 milliseconds. Okay. So here turnaround time if you want to calculate it is 23 milliseconds waiting time and the execution time for P2 is 5 milliseconds, isn't it? So 5 milliseconds, so here it is 28 milliseconds. I have written this. Next work what I am having is to calculate the average. Okay, average of 6, 0, 16, 7. Sorry, it is not 7, it is 23. Okay, average of 6. Okay, average of 6, then average of this 0, then 16, then this 23. This is the sum. Okay, I will write it with a bracket, that will be easy. 6 plus 0 plus 16 plus 23, if you do, you will get the answer as 11.25 milliseconds. And here if you want to calculate the average, here it is 6 plus 0 plus 16 plus 23. Here it is 16 plus 6 plus 23 plus 28. Here it is 18.25 milliseconds. Here it is 11.25. Here it is 18.25 milliseconds. Okay. I hope you understood the numericals of this scheduling algorithm. Thank you.